Hello and welcome to my channel, where I show you easy step-by-step guides for labs and activities that you can do at home or at school. For today's activity, we'll be looking at color deficiency, or more commonly known as color blindness, and how it affects someone's ability to distinguish between different colors. In order to do this activity, we have to change the line different from this to this. And once we're under red light, you can see how difficult it is to distinguish between different colors. So let's get started with today's activity. For this activity, you're going to need a standard lamp like this one. You can buy them in bulk from any hardware store. A red light bulb. That'll be our light source. When you get a light bulb, make sure you have one like this that has a red filter on it. The reason being that this will only produce red light. One like this that has red coils in it, while it looks like it only produces red light, this will actually produce a very small amount of blue and green, which will affect the results. Lastly, you're going to need something to sort. The pony beads like these from the craft section are great because they come in a variety of colors, but you can also use things such as candy or colored discs or something else, as long as it has a variety of colors to it for sorting purposes. As with any activity, please be safety conscious. You are dealing with small objects. You do have a power source. You will have cords running through the area, and you also have to worry about a lamp and a heat source. So please be safe. And now we just take our lamp, install the light bulb, set up the lamp, add your beads. Now with the red lights on, your room should go from this to this. And so now we can sort out our beads. When you start this activity, probably the easiest thing to do is separate your darker colors from your lighter ones. What I'm doing is trying to sort them based on the color I can see right now. And some of them are easier to sort together, obviously. Some of them are a little tougher. So after a few minutes, you should end up with something like this, where you have a bunch of different groups all sorted together. After we get them all sorted, it's time to turn on the lights and see what the results are. And you can see now how many you got right and how many you got wrong. So here are the final results under red light, and these are the results under normal light. So let's talk about what happened here. So the easiest way to think about a spectrum of light is to think about a rainbow. You have red, orange, green, blue, violet. If all light is reflected, you'll have white. And if all light is absorbed, you'll have black. The human eye is a sphere with a lens that allows light to enter. And on the back of the eye are specialized proteins called cones. And they absorb red, green, and blue light. As light enters the eye, it'll react with that cone of the same color, such as red will react with red, or blue will react with blue, and green with green. Because we used a red light bulb, it only produces red light. This means that only the red cones are being activated. And we can see that in our final result, as these four beads were very easy to distinguish from each other. And even this dark green was distinguishable from the reds. But then our white, tan, pink, and yellow were very difficult to distinguish from each other. The gray, light green, blue, and brown were also difficult to tell apart. On the far end of the color spectrum, our medium blue blended with brown, and our dark blue blended with black. And on this end of the spectrum, the only color we could distinguish by itself was purple. And if you compare the results in a red light, you'll notice that all of the red marks have disappeared because the whiteboard itself is actually reflecting red light. Meanwhile, you can distinguish between the red beads and orange, but you can't really distinguish between the others. They're back to their groups. When someone is colorblind, they have a mutation in the gene that produces these cones. As a result, the cone is made incorrectly and doesn't receive light. That color of light will still enter the eye, it just can't be processed. So what causes color deficiency? The gene to see blue is located on chromosome number 7. The genes to see red and green are located on the end of the 23rd chromosome, right next to each other. Women inherit 2 X chromosomes on the 23rd pair, while men only inherit 1 X and a Y, which means they'll have 1 copy of each of these genes. Because men only have 1 copy of these genes, if there's any error in them, it will be expressed. As a result, men are more likely to have color blindness than women. Because there's 2 copies of the blue trait, there has to be an error in both of them. If there's only an error in one, this one will still produce blue cones, people will still be able to see blue. So there has to be, both of them have to be damaged before someone cannot see blue light. However, with the green and the red, they're very similar to each other, and they're also located near each other. As a result, they sometimes will accidentally splice together. When they splice together, the person will have 1 proper protein and 1 that's partial of each of these traits. This protein will not function as a result. To make it even more complicated, we can have anywhere from 1 to 3 green traits per person. This can lead to multiple different scenarios of colorblindness. They could see green because the red is damaged, they could see red because the green is damaged, or they could see red and green, but might have issues differentiating some of the shades because of a red-green splice. As a result, there's different types of colorblindness. One where somebody can't see blue, can't see green, can't see red, or maybe can see all 3, but will struggle to differentiate between some shades. If you found today's video helpful, please like and subscribe. I try to post a new video every month. Thanks for watching.